Hi all, welcome. Hopefully you guys can see my screen. Leslie, does everything look the way it's supposed to?
Yes, I see your goals.
Excellent. So this link that's right here for all of you to type in is there if you want to download data and kind of walk through the process that I'm going to demonstrate with some of these GDAL utilities. You don't have to do that. This is meant just as an option for folks that like to work with data instead of just listening or watching me show you how to do something. A couple of goals. Most of my life is as an academic, and so we're supposed to have goals and learning outcomes. Mine are pretty simple. One, I want to demonstrate just how powerful and accessible a lot of the raster support within QGIS really is. For some folks, you may be interested and curious because you want to be able to do GIS for a consulting business that you're starting, or just want an alternative to some proprietary options that are out there. And then, you know, along the way, demonstrate that a lot of these common utilities, at least that I use, but certainly that I think a lot of you would make use of in your day-to-day GISing, isn't that scary. I honestly primarily make use of maybe a half a dozen, and I just copy and paste from either a text file that I have or a website that I have bookmarked. And so a lot of times if I just want something done quickly, that's what I'll do. Jump in, copy and paste, and then I don't even open a GIS to get the information that I need. So that's the link. I'm going to transition to where that link takes you, which is to this page. And like I said, many of you, when you see this syntax here, it might remind you of your ArcInfo days, or it might remind you that you've never had to encounter that. But it really is, in many cases, faster than opening up a GUI and clicking 20 buttons to get it to do the same thing. So what I've done already is downloaded this data. So again, if some of you want to march through that and download your data while I get started setting things up and explaining what we're going to do, feel free. This is not going to be a comprehensive overview. I'm going to switch pages here. If at any point I'm either talking too fast or switching too quickly, I'm trying to be mindful of the fact that there's a bit of a lag here between what's happening on my screen and what you're viewing. Just let Leslie know, and she can interrupt me and tell me to slow down, or maybe hurry up. So we're not going to go through every single one of these utilities within GDAL, partly because not all of them are supported within QGIS. And really the point of this is to demonstrate that you have access to these without having to use command line tools. But what I do want to do is, in many cases, remove the black box from the QGIS interface and let you know what's actually being utilized when you're clicking those buttons. But we will go through a number of these. And this link is also in there. This is Derek Watkins put this together for both OGR and GDAL. Just simple command lines here that you can copy and paste. So we'll come back to some of these in just a second. So we're going to work with some Vermont data. Surprise, surprise. I've already loaded this up, but the time that it took me to load this interface and navigate to the specific layer that I want, and if I want to go find information about this layer, I can come in here and navigate through these, and it will give me information about this particular grid raster file. Or, and again, this is me just demonstrating some of the simple ways that we can use this command line. We will get to QGIS shortly. So I can see that I have some GIS data in here. I'm interested in this DEM file. So what I might do is just paste that simple command in there and ask for some information, which it will give me. And it took a lot less time than opening up that interface and navigating through those drop-down menus. So again, depending on what we're trying to accomplish, it may actually be faster to go that route of copying and pasting than opening up the full-blown GUI. I won't harp on this too much. All right, so what I want to do is walk us through both the tools that are immediately available and then a few that are perhaps hidden, and maybe give you a sense that much of what we often do in our day-to-day GIS world is something that's accessible through this interface. This is not meant as a sales pitch for QGIS. I use ESRI products every day, so I'm not poo-pooing any particular software package or approach, but just that this is really a viable option, and you probably heard either Leslie or I talk about this at a roundtable. And then I want to show you some of the ways that we can access tools, related raster tools that perhaps aren't associated with the GDAL library. So for those of you who are following along in this silly web page, some of the things that we might typically do is to translate. So we might want to convert between formats. We may want to clip or crop the data, etc. So I'm just going to walk us through a couple of these tools. So in QGIS, much like in ARC, if you're familiar with that environment, we have options for both vector and raster data. When you add in other plugins, they get put under this raster dialog. So you may or may not see some of the tools that are listed here depending on your version. I'm running the latest 2.6 version. So if you see something here that's not in yours, it may have something to do with a version, or it may have something to do with a plugin that you don't have installed. And this is an example where this is a terrain analysis plugin that will let you do a variety of different surface analyses. But this is not the GDAL equivalent. The GDAL equivalent is hidden down here under DEM and terrain models, and we will get to that. So our first thing that we might want to do is convert data. So this data right here, this particular layer, you can see if you look at the file name there, or the path name, this is listed as a TIFF file. I've already created a TIFF file from the original data that I downloaded from VCGI. So again, this is not necessarily complicated processes, but this is something that we can do relatively easily. And in fact, more often than not, when I want to convert between formats, I jump into a QGIS interface. There's typically fewer clicks involved. And so I can go to this conversion and use the translate utility. So this option is actually showing us the code, the command line code that we would use to make this, or to convert between these formats. And so as I add things, if I say I want this to be the output to be a dem.tiff file, we start to add information here. I can, in the same interface, I can also change my projection. So I can do two things at once. And if you have a folder that's full of raster images, you can batch process all of those. You can change a variety of parameters. All of these parameters are listed on the GDAL documentation site. So if we go back to GDAL and we go to translate, it explains what all of these different parameters that we parse through this process actually mean. And you'll notice that not all of them are supported in that dialog. There's a lot more that are listed here than are available within the QGIS interface. So, but the nice thing about this is we do two things at once. Often I find myself in other interfaces converting and then reprojecting through another step. But again, all the code, I think what's nice about this is that it's showing how this translation is happening through the actual command line code here. So the other thing that you could do is if you have processes that you run over and over, is you could set this up. If command line is completely scary, you could set it up in here and then copy and paste that into a text file that you could use over and over again. Depending on the size of your raster data set, that probably won't be necessary. So I've already done this conversion. We can go back and grab this TIFF file. But what we might want to do is crop this data. And I've downloaded the town data, And let's say that we're interested in Mansfield. So I'm going to go through this. I did not do this ahead of time, just also to demonstrate some of the similar functionality that QGIS has to other GIS software packages. So we'll go to Underhill. And what I'm going to do is crop the DEM to that particular town. So I'm going to save out just the feature that I have selected. We'll call this Underhill. And I will add that to my map when I'm done. And I now have a shapefile just for the town of Underhill, which means that I can now crop my raster layer just to that. Again, using raster and extraction in this case. So probably the hardest part of using, well, of switching between any software package, and certainly GIS, is finding out where these tools are hidden. And so it's worth taking some time just exploring the different drop-down dialog menus. And in some it's called crop, and in others it's called clip. The way that it was always explained to me is that you clip vector data and you crop raster data. But I have since heard it a variety of in both contexts. So we will create an Underhill DEM. And we will save this out as a TIFF file. You can change the node data value if you want. You can set your own XY, but we are going to mask this with Underhill. And so again, you can see everything that's happening in the command line here using this GDAL warp utility. Oops, it looks as though I clipped the wrong one. That's bizarre. Let me do that again. I think I clipped the Mansfield one. Yeah, sorry. So again, I'm just taking the DEM, and now it's properly the proper layer, and I'm going to crop it to the Underhill vector layer. And let's see if that worked. I still have the same one. All right, we'll try this one more time. Yep, I do not want that. All right, clip my DEM. With Underhill. Interesting. Perhaps I cannot overwrite this one. All right. So I needed to not give it the same name. I'm just going to change the transparency. I know I'm going a little fast here. I'm just going to change the transparency on my 0 value so that it looks like the original DEM. Okay? So this is a process that we typically do in GIS, clipping or cropping raster data, depending on which term you're familiar with. And in many cases, if we also want to change the format while we're clipping or cropping, we can also parse that through GDAL. That's in the command line, not necessarily through this GUI interface. So some of the other things that we might want to do, if we scroll down this list, we could pull out projection. Oops, sorry. We can pull out the projection. At least in Vermont, we're lucky that almost all of the data, I think almost all of the data is in Vermont State Plain. But if we do go and grab data, and so for those of you who are, if anybody is, grab data from somewhere else. In this case, if you haven't seen LibreMap before, it's a great place for DRGs. But if we go and grab data from this site and download the DRG file, which I've already done, this won't be in Vermont State Plane. This is just in standard NAT83 UTM. And so one of the often most frustrating things is trying to figure out what projection you're dealing with. The newer versions of QGIS, basically since 1.8, are much better at identifying the layer SRS when you bring them in. In earlier versions, you would often have to set that projection for each layer that you were bringing in, or often just oddly some layers when you brought them in, and it wasn't consistent. It's a lot more consistent now. And so one of the ways that we can do this in QGIS is to just go to the Properties dialog box of the raster layer itself, and we can go to Information, and it will tell us about the properties of this. So we can look at statistics, the origin, etc., and we can also go and look at the coordinate reference system. So this is UTM NAT83, and if we go to Mansfield, we have NAD27. So the Libre map data is actually NAD27 zone 18. If you want to run this through the command line, you would get the same type of information like this. It would come through. It's just a lot faster. Or, and so there's a little redundancy in here, you can actually extract the projection from an input file and create a PRG file. So if you have a variety of files that don't have projection files, you can create them using this utility. Again, there's a bit of redundancy here because you can go and look at it under the Properties menu if you just want to know what it is so that you properly reproject. If you do want to reproject, so this is lining up fine because this is the SRS, the coordinate system is identified properly. But if we do want to project, we can use the GDAL warp. And so migrating between GIS interfaces, part of the challenge is figuring out where the tools are hidden, just the buttons themselves, and then sometimes it's figuring out what the word that you should be searching for. So you might be used to creating a hillshade in ARC and then go into something like Manifold where you might create a shaded relief map, and in GRASS you can create a shaded relief map. In QGIS, depending on the plugin, it says shaded relief map. So here, if you're used to reprojecting or projecting data, it's the GDAL warp utility. So we can take our Mansfield DRG and we can output this to Vermont State Plane by setting a target spatial reference system here. And so if you frequently use different types of data, you'll have a list here of things that you've used. And so I've used Vermont State Plane. So I can just select that. You can also search. So if you just search for Vermont, it will give you a variety of options here to choose from down here. These are the ones that I've used recently. So we will just go with what we've been using. Again, you can change different parameters. You can. What's nice is some of the GDAL utilities are being rewritten so that they support multi-threading. Not all of them do that, and that process is something that, as many as you know, is user supported. So not all of them have this functionality, but that's the direction where we're going. So let's make sure here we're just going to reproject this. And so again, it's in the same location, but now they're both in the same spatial reference system. So again, just very common tasks that we typically use in a GIS. I'm going to remove this one. Some other things that we often do. So again, just marching us through here, we extract, we can use GDAL warp, we can assign projection, but these DEM tools, this is what many of you are probably familiar using in ARC through the Spatial Analyst Toolbox and surface functions if you have a 3D analyst. And so we can do many of the similar functions. There's a terrain analysis plugin that you can do slope, aspect, etc. But we can also do this under analysis and DEM. So this is using the GDAL DEM library utility. And basically what we want to set first is what we're actually going to calculate. Hillshade slope, terrain ruggedness, topographic position index. You can create a colored relief pretty easily. So we'll just start with a basic hillshade. And again, this is something that is very common and easy to do. One of the nice things about QGIS, and also if you haven't seen it before, is a GIS package called Whitebox GAT, G-A-T, all capital letters. And I'll add that to the that web page as a link. But what's nice is that it easily exposes. You can find this in a lot of the ESRI algorithms, what they're using, but oftentimes it's a fair bit of work. And so you have an option here of using 2 different algorithms to calculate hillshade slope and aspect. And for most of the things that we probably do, this won't affect, because often they're just used for aesthetic or visual purposes. But if you have a more smooth or rough surface, is one of the things that informs which of these that you would choose. But at least it's exposed here, and we know which one that we're choosing. I'm just going to leave it as the default. The software package I mentioned previously, Whitebox GAT, every algorithm, you can actually see what code is being run. So instead of just seeing the syntax for how you're using this particular GDAL utility, the entire algorithm is exposed in a similar dialog box so that you can go in and visually explore what's happening. So we're going to run Hillshade. Again, similar if you've used ARC, the Hillshade option in ARC, we can set a variety of parameters here. And we will just let this run. Oops, again, I did it on the wrong. I'm not paying attention to my layers here, so I'm just going to run this again. And what you'll notice is that they produce Hillshade with the same name here. So we produced a Hillshade. Again, we can mask this off so that we don't see that in a similar way that I did with the symbology with the DEM. The other often used of slope and aspect, those are relatively easy to set as well, and some of you may be interested in more analytical tools of terrain ruggedness, looking at what is the relief between individual sections of your raster layer. So again, most of the things that I'm going to show you are more elevation based. I don't do a lot with raster imagery, although there is some support for that in the GDAL library. So we have options for all the typical common surface analyses that we would use in another GIS. We can contour data, digital elevation data. So, and again, this is our extraction. So again, figuring out where this is hidden, we can use this contour tool. We're going to input just this DEM, not the entire one. And we will call this, we can set our interval, and we can define what the name is that we want in the output vector table. So nice, visually, aesthetically pleasing. We don't really need to produce this because in Vermont we're lucky enough to have contours, and with more lidar coverage we'll likely get even better contour production. But again, if you're working in a region, maybe you're getting some Canadian data that that doesn't have access to higher resolution contour data. But again, just showing you that we have access to these various tools. We can merge raster layers. So this is something that you may want to do if you're using, I'll just pull up one website as an example. If you're using Aster data, so you can download 30-meter data for the world, and you may be interested in working with it as a single layer. So similar to the command line or the tool that you have in ArcMap for Mosaic to raster, that's what this utility does in a similar way, is to merge different raster grids. And then with imagery, you can use that for imagery. It is not as seamless as some of the other algorithms because there's less of an emphasis on imagery in many of the GDAL libraries. Building pyramids. Building pyramids is relatively easy, similar to how we run this in Arc. This is an example, however, where I often do this in the command line because it runs much more quickly than running this through the GUI. And so if you are just using Arc, or sorry, if you are just using QGIS, just the GUI, you can go in here and build pyramids just by going into, I'll go through this again, I went rather quickly. We go to the properties menu of the layer, and then we go to the, looks like a pyramid, we can actually we can build pyramids in here, in a similar way that you can right-click in our catalog and create pyramids. So for something like this, we don't really need to do that. Pretty low resolution already. And last one that I wanted to show you, or at least mention, was polygonize. So again, early on, this was, we would refer to this as R2V, raster to vector algorithm, and so you could do something like take a land use raster and convert that to a polygon, and vice versa. You can go from vector data to raster data, and so this is accessible under let's see here, conversion. So you can use the rasterize or the polygonize tool. All right, so the breadth of tools that we typically use, at least that I typically use, I think are generally accessible through the GDAL library that's here. Another way that we can access it, which may or may not be more a smoother transition because it looks more like our catalog, is to use the processing toolbox. And this was introduced, I think it was introduced in QGIS 1.8, but it was called the Sextante toolbox, and it's been migrated over to this processing toolbox. And what's nice about it is, similar to our catalog, or sorry, our toolbox, we have a drop-down of all of our different tools, so we can do all of the same types of things that we can with this drop-down menu, except we don't have to search through, we don't have to navigate through those menu bars that are just listed here. Again, similar to the ARC interface. And there's a few that are in here that aren't in here, and they are things that I typically don't use myself. So, but the other nice thing is that we have access to GRASS and Saga. So I know that this was mainly about GDAL, but again, my big overarching goal was to demonstrate the raster processing tools that are available in QGIS. And so if we go and look in GRASS, we can see that many of, again, they're not all supported, but many of the tools that we maybe you've used before in GRASS, but they're now accessible through processing. And if you have used QGIS before and you've used just turn this on so we can see the difference. If you've used the GRASS plugin before, you notice I don't have this turned on, but I still have access to these algorithms because these are now being parsed through the processing toolbox. This still required you to create a map set and set up a database that was similar to the type of a database that you would create using a GRASS standalone software. This doesn't require that at all. You can use your normal, however you normally set up a database or organize your data, and still make use of these algorithms. So some of them are supported in GRASS, and this is GRASS 6, and some of them are supported in GRASS 7. And so there's some overlap between the two. And then also Saga. So Saga really is a raster GIS. It really focuses on raster analysis and primarily geostatistical analysis. So you can see that you have access to a variety of different kriging tools here. This again is typically something, at least from the ESRI point of view, that we need the geostatistical analysis to have the type of control over the grids that we interpolate here. You can see there's a bit more imagery tools here and a fair bit of geostatistical algorithms that you can use. What's nice about this processing toolbox is that it's taken really powerful tools out of interfaces that weren't necessarily intuitive or easy to use and made them accessible in a relatively accessible interface. So if you have used GRASS before, many people are frustrated by that interface. It's more of a Unix-looking interface. Saga was also frustrating for folks to work in. And so what's nice is that they've all been kind of compiled into one nice accessible GUI. And then a couple other R, so some of these are statistical packages that you can use, like summary statistics, point pattern analysis. These are things that are accessible. And then some of you may be interested in hydrologic modeling, and this TOW-DEM is very powerful. There's an extension that you can add, or a toolbox you can add into ARC, map window, but these are all available in here as well. So you can, I don't know why they're in reverse. They should be from top to bottom here, but you can work through this workflow and produce watersheds using this TOW-DEM hydrological analysis tool. So getting away from GDAL a little bit, but just giving you a sense that if you've used GRASS algorithms before, they're now accessible through the processing toolbox. If you, and not many folks have, but if you have used the Saga GIS, then they are also accessible. The other thing that I'll show you, just because I have you in front of me, is that we can, whoops, wrong one, is that similar to ESRI's model builder, there's also a model builder that's just called the visual modeler in ARC, where you can create, in the same way that you can with model builder, workflows that you can then run over and over again. And then you can save these out. Not sure why none of my layers are showing up here, but then you can save them as models that you can then run. And so if you wanted to run contour lines from points, this is the dialog box that you would see, but there's a graphical interface that was created to make these run. So again, if there's raster processing functions that you run repetitively, and you are interested in migrating out of a proprietary GIS, that modeling workflow environment exists in this processing toolbox as well. So I think, I'm not sure if nope, good. So I think I just wanted to lay everything out there so that people could see what was accessible, and then I wanted to let Leslie parse through questions so that if you have something that you want to be able to do outside of ARC or some other software package, and I may or may not know, but I'm actually using QGIS more than ARC these days, that there may be a tool that you're looking for that I haven't shown, but that I can point you in the right direction. So Leslie, I think we have plenty of time for questions, and so hopefully some came through.
Sorry, I almost forgot to unmute myself there. Yes, so here we have a question, and I encourage everyone to send in your questions now, because It takes a second, I think, for them to get transmitted. Okay, so here's a question from Mike. It appears GDAL has many capabilities we're used to in ArcGIS. What capabilities does GDAL not have compared to ArcGIS? And he lists some examples, like from analysis, cartographic output, etc.
Well, I'll start with probably the easy answer, which is the cartographic output. So GDAL is similar to Arc Toolbox in the sense that it typically doesn't, it's not responsible for producing the map product itself. And in general, I would say that if I have a criticism of the QGIS interface, it is the cartography side of things. It is not as, it's not as easy to create the type of cartographic products that we might want to, and that partly is learning curve coming from ARC, and partly just because some of the tools aren't there. It is always getting better, though. There are some things now that QGIS does quite well with layer blending options that really are superior to ARC, and there's also line rendering is also nice, better, anti-aliasing on the outputs. So from that perspective, I don't know that GDAL has any advantage over ARC from the cartographic side of things. Processing-wise, I'm trying to think of something that I've tried to do that I haven't been able to do. I guess probably the thing that I've encountered the most is that people are developing, state and federal agencies develop, I think, more for ESRI products than others. And so in the state of Vermont, a good example would be, and I think this is changing, but would be the SGAT software that was developed to do fluvial geomorphology assessment. And that was written solely for ARC. And if people didn't have the right version, then it just didn't work for a while. And I think that we're in a transition period where that's changing, but I don't know the details of that. So I think that's probably where I've encountered the limitations, is that there's an algorithm or a tool that has been created that hasn't been ported over. Let me think just for a second about other possible things that I've encountered. I guess the other thing that I'll say is that ARC builds in a database structure. So in the geodatabase by default, so that you're using tools in ARC catalog that are intimately linked with the geodatabase where these are being stored. And for me, if you guys see the little Pele the elephant up here, anything that I create is in many projects are being dumped into a PostGIS database, and that's just one other extra step for me. If I use GDAL, I often have to then move that data layer into PostGIS. So I think from a streamlining perspective, some of the ARC benefit is in the fact that those tools are running and exporting directly to a geodatabase. Okay. I can't offhand think of any specific analysis that I've wanted to do. The other thing that I didn't show you, and so some people may be interested in this, I can't remember if I had it turned on. Yeah, I don't have it turned on, is and this is easier for folks on Windows. There is a way to do this on Mac. I've still yet had to figure out how to make this happen. But if you're familiar with using the last tools, the lidar algorithms, these are also accessible through the processing toolbox. That's outside of GDAL, but that is something that GDAL is not. That's a limitation, I would say, relative to ARC, but it's not a limitation of QGIS if you're running it on Windows. Right.
Okay, we have another question from Scott. Or another question, and this one's from Scott. Can you create a true single-file georeferenced TIFF, not a TWF? And he says, I believe GDAL can do this, but he has a question mark there.
Oh, you mean where it's actually the projection data is written into the header?
Yeah, I think that must be what he means.
I I believe, let's just test this. I've got Mansfield right here, and I believe that this does have a, I'm just going to double check, this does have a,
TWF.
yeah, so this does have a TIFF file and a world, nope, this is just a DEM, TIFF, and a PRG file. Let's just see if we can save this as, and so this is doing GeoTIFF. I'm going to save this into a different folder just to see how it creates this. Well, test and teast are roughly the same.
Teast.
So that just exported out that TIFF file, which suggests that saving, I typically when I'm doing conversions, I just right-click and save out as a raster. I don't go through this other option here. But it appears as though it's that simple as just right-clicking and saving out as a DRG. Is that, Scott, is that what you were asking?
I think that's what he meant. Yes, he says yes.
Okay.
Great. So Len asks, does the QGIS Desktop installation also give one access to full command line GDAL?
Yes. So I haven't. So when I bring up my terminal here and I ask for anything GDAL, whoops. Let's go to the desktop here. And I ask for run that command. I didn't install GDAL separately. So when I install QGIS, GDAL, the library itself, is installed automatically. I didn't have to do any other installation on that. This is, I believe, true on a Mac. I do believe that you have to install separately on a Windows. Because last week I tried to do something on a PC in our lab, and opening up the command line didn't just run by default. But on OS, it's just there.
Okay. Now Mike has a follow-up to his question about what GDAL can and can't do.
Yep.
And he says, and I think I know the answer to this because I think it's what you're doing, but is there a separate open source cartographic program out there that works in concert with GDAL? And I assume the answer to that is what you're doing, which is QGIS. Right?
Oh, well, so GDAL is a library that you don't even need, well, we know we don't need a front end to run the command line, but it's just a library. So there's actually, if folks would like access to GDAL tools, you can, so this is on that page that I shared, there's actually a ARC plugin that allows you to make use of a variety of these GDAL and OGR tools. It's also accessible through Map Window, GVSig. It is basically just, these are algorithms that are being ported into whichever GUI that somebody decides to translate them over for.
Okay.
So I guess my answer to that question would be is you don't need this front-end GUI, but it is accessible through a variety. I've just chosen to show QGIS mainly because we also have this processing toolbox. Mm-hmm. And that gives us access to a variety of other raster-related algorithms.
Okay. Okay. Len has another question. Have you used QGIS for lidar or mosaicing a large number of rasters?
I have not used it for lidar, mainly because of academic licensing. We have access to a variety of other tools, but I have mosaicked Raster data for, I guess it was maybe 24 tiles, and it worked fine. I mean, there's some inherent issues with Raster data that, regardless of the library that you're using, but mosaicing elevation data, at least I found, is pretty good. I have had some issues with imagery, but yeah, yep.
Okay.
And again, if you use the build pyramids function, then It's not as though you're limited by the fact that you create this large raster and then you can't downsample it so that you can have different zoom levels.
Okay. And our last question, unless people want to send in more, because there's still plenty of time, Paul asks, or says, I would like to make a workable, editable shapefile from the 2001 land cover raster database. With 2 question marks, meaning, I guess, can he do that using these tools?
I would say yes. So for the entire state?
I assume that's what he means. He's not limiting it in his question.
Yeah. I have done this for, well, I've had my students do this for Rutland County. And yes, it's, one of the steps that you have to do. So when you, let's see here, when you go from raster to vector here, you need to make sure that you do know what the field name is that you want to convert. So this is similar in ARC where you set a, what are you using ID, are you using, whatever. And so make sure that that's set to the land use code value, whether that's 0 for water or whatever. I would say, I haven't tried it for the entire set, but I don't know how that would be different than running this for a county. So we've done this at the county level.
Might just take a little longer.
Yeah. And again, with that, 2 comments on that. This right here, once you set up where you want it to go, I would, say it will run a little bit faster if you just copy and paste that into a command line and let it run. Yeah.
Okay. All right. If there are any other questions, now is your chance to send them in. That was a good set of questions we got.
Yeah, and I guess what I will say is, so as people ponder, or if you go back and look at that web page and do have more questions like that, or sorry, who was that last question from?
Paul.
Paul. One of the other thing, I don't know how many people are still hanging out here.
Everybody's still here, actually.
Cool. If people have, this is my plug. Every spring I teach a GIS course. If people have things like that that you'd like to see the land use converted over, and I mean, there's issues. I think we all kind of recognize the issues in doing some of these conversions. But if there are things that you would like a workflow developed for, or just something like producing a layer like that, don't hesitate to contact me, and I can pass this off to students. And I'm very mindful of the fact that students need someone looking over their shoulder. So I've had pretty good luck. Students working with Stone Environmental, pretty good luck of making sure that the deliverables are of high quality. So don't hesitate to reach out if you have other questions, or if you do have an idea that you'd like somebody to tackle but you can't do it in-house, or just are curious and want to see what students can produce.
That's a great reminder. All right, I think we're all set. Yep, and Paul says thanks to that.
Yep, no problem.
All right, thank you very much, John. And just because I realized I didn't really say it at the beginning when I introduced you, John's a professor at Green Mountain College in Poultney, Vermont. I think I forgot to mention that at the beginning, so I apologize for that. Thank you, everybody, for participating, and remember, this has been recorded, and it is going to be posted within the next day or so at our VCGI's YouTube page, and you can get to it either by just searching on YouTube or by the link that's to the left on the front page of our website. And I will also be posting links to the information that John has sent me at the event archive page in our website. You just have to drill in a little bit into the event section and the event archive and look for webinars. So thank you again. Let me just make sure there's no last minute ones. Thank you again, John. And yeah, there's just thank yous from everybody coming in. So it was great. Thanks.
Wonderful.
Have a great day, everyone.